Brake test on 3-phase induction motor. Are performance characteristics of 3-phase induction motor. Are speed torque characteristics of induction motor. These all are the different names of 3-phase induction motor. Brake test on 3-phase induction motor. Are performance characteristics of 3-phase induction motor. Are speed torque characteristics of 3-phase induction motor. Load test on 3-phase induction motor. The other name for brake test is load test on 3-phase induction motor. Aim to determine the efficiency and performance characteristics of 3-phase induction motor by performing a brake test. Apparatus required: voltmeter. The type of the voltmeter is MI. Then the rating is 0 to 600 volts. Of quantity 1 number. Ammeter. Type of the ammeter is MI. MI means moving iron ammeter. The range is 0 to 10 amperes. Quantity is 1 number. Wattmeter. The type of the wattmeter is electrodynamometer type wattmeter. The range is 10 amperes, 600 volts, UPF. 10 amperes is the current rating. 600 volts is the voltage rating. UPF means unity power factor. There are two types of wattmeters are there. One is UPF, another is LPF. UPF means unity power factor. LPF means lagging power factor or low power factor. We need two wattmeters of UPF. Tachometer, digital tachometer. The range is 0 to 9999 RPM. And connecting wires, which are explained as apparatus required are voltmeter, which is MI. Now for voltmeter, one is a common, another one is 300 volts, and the next one is 600 volts. You need to place 0 to, this meter is used to measure 0 to 300 volts or 600 volts. Here we are applying, here used for 3-phase. The voltage is 415 volts or 440 volts. That's why the meter you need to connect is, one is common, another one is 600. Coming to voltmeter, the range is 0 to 5 by 10 amperes. Here this ammeter is an MI ammeter, moving iron ammeter. The connections are common, and this one is 5 and this one is 10. If you observe the scale from 0.51, with which the distance is very small. If you observe from 3 to 3.5, the distance is 3 to 4, the distance is large. Means here you can observe that the scale is non-uniform in case of MI instrument. Similarly for voltmeter also, the scale is non-uniform. If you observe 25 to 50, this is the distance, whereas from 150 to 175, this is the distance of the scale, which the scale is non-uniform. These meters are MI meters. One is voltmeter, another one is ammeter. Another equipment we need is wattmeter. For wattmeter, there are 4 terminals. One is EM and EL, common, and voltage. Now based on the voltage we are connecting, whether you need to connect a 600 volts or 300 volts or 150 volts. Here we are using this voltmeter for a 3-phase. Now voltage reading must be in the scale of 600. You need to connect voltage must be 600. If you observe this is a wattmeter, UPF wattmeter. The type of this wattmeter is dynamometer type. Now if you observe carefully here, B1 and B2 are connected. If B1 and B2 are connected for the wattmeter, the current rating must be, if you observe that the bottom B1 and B2 are connected, if B1 and B2 are connected, the current range must be 10 amperes. Here is 10 amperes, and we are connecting, if we are connecting, voltage is 600 volts, here is 10 amperes, and the voltage is 600 volts, then the multiplication factor must be 4, corresponding 10 and 600 multiplication factor must be 4. Now here also, if you observe for the other wattmeter also, here B1 and B2 are connected. If B1 and B2 are connected, and if you are connected to 600, then the scale is 600, and B1 and B2 are connected 10 amperes, then the multiplication must be with 4. Here B1 and B2 are connected. If B1 and B2 are connected, the current must be in 10 amperes. Like that, if we are using another type of wattmeter, there, if we observe this one, the scale here in this case only B1 is connected to E2 and B2 connected to E1. In that case, we observe the wattmeters. If B1 E2 and B2 E1 is connected, then the current is 10. Now like that, if you connecting for here, if B1 E2 and B2 E1, then the it will be, current will be 20 amperes. Then the range is 20 amperes and 600 volts, which will give multiplication factor 8. But the rating of that induction motor is 7.4 amperes. That's we are connected to B1 and B2 are connected, which is 10 amperes. This, and we need to use, if you press this button, then if you rotate, now this one rotated will be placed in the shaft, then automatically it will display the speed of the induction motor. These are the S1 and S2 nameplate details. The voltage rating is 415 volts and the current rating of the 3-phase induction motor is 7.46 amperes. The power rating of the 3-phase induction motor is 5 HP. The speed of the 3-phase induction motor is 1500 RPM. Frequency of the 3-phase induction motor is 50 Hz. Voltage units are in volts, current units are in amperes, power rating is in HP. HP means horsepower. 1 horsepower equals to 735.5 watts. Sometimes you may ask in BHP. BHP means British horsepower. 1 BHP equals to 746 watts. RPM means revolutions per minute. Frequency units are in hertz. These are the circuit diagrams. If the circuit diagram is consisting of terminals of L1, L2 and L3. If the circuit diagram is consisting of terminals R, Y, B, then this is the circuit diagram. Sometimes the circuit diagram consisting of terminals A1, A2 of phase A winding of 3-phase induction motor, phase B winding is B1, B2 and phase C winding is C1 and C2, which are the 3-phase windings of a 3-phase induction motor. This theory. The brake test is a direct method of testing. It consists of applying a brake to a water-cooled pulley mounted on the shaft of the motor. A rope is wound around the pulley and its two ends are attached to two spring balances S1 and S2. The tension of the spring balances can be adjusted with the help of spirals. Then two spring balances are S1 and S2, S1 minus S2. The force acting tangentially on the pulley S1 minus S2 kgs. Therefore, shaft torque TSH equals to S1 minus S2 into R, which units are in kgs. if if you want the units in terms of Newton meter, the formula you need to do is you have to multiply with 9.81. Then it will be 9.81 into S1 minus S2 into R, which the units are in Newton meter. A three-phase induction motor is an electromechanical energy conversion device that converts a three-phase input electrical power into output mechanical power. Three-phase induction motor consists of starter and rotor. The starter carries a three-phase starter winding supplied from a three-phase supply displaced in space by 120 degrees, while the rotor carries a short-circuited winding called rotor winding, drives its voltage and power from the starter winding through electromagnetic induction. Hence, the name is three-phase induction motor. The working principle of three-phase induction motor can be explained as when a three-phase starter winding is supplied from a balanced three-phase supply, a rotating magnetic field is produced in the motor. The RMF rotates around the starter is called synchronous speed. Synchronous speed Ns equals to 120 F by P, where F is the frequency and P is the number of poles of the three-phase induction motor. Therefore, Ns is equals to 120 into 50 by 4, which is equals to 1500 rpm. The RMF passes through the air gap and cuts the rotor conductors, which are still stationary. Due to the relative motion between the RMF and stationary conductors, an EMF is induced in the rotor conductor. As the rotor winding is short-circuited with the help of end rings, a current flows in the rotor conductor. When the current-carrying rotor conductors are placed in the magnetic field, the rotor conductors experience a mechanical force. As a result, the sum of mechanical forces on the rotor in the same direction produces a torque that moves the rotor. Hence, in such a way, the three-phase input electrical power is converted into output mechanical power in a three-phase induction motor. Procedure: make the connections as per circuit diagram. After completing the connections, switch on the supply using TPST switch. Start the motor with the help of start to delta starter. Time speed gains the rated value. Note down the readings of voltmeter, ammeter and wattmeter at no load. Now increase the mechanical load by tightening the belt around the brake drum gradually in steps. Note down the various meters readings at different values of load till the ammeter shows the rated current. Reduce the load on the motor finally and switch off the supply. Precautions: avoid the loose connections. Don't touch the circuit connections while power is on. Take the meter readings without parallax error. Cool the pulley while the experiment is performed. While measuring the radius of the pulley, effective radius must be considered. From R, we need to give a wire from R to TPST switch first terminal. TPST switch first switch second terminal is connected to the first fuse first terminal. First fuse second terminal you need to connect it to start to delta starter. From Y we need to give connection to TPST switch second switch first terminal. TPST switch second terminal is connected to fuse second fuse first terminal. Second fuse second terminal is connected to start to delta starter. From B phase is connected to TPST switch third switch first terminal. Second terminal is connected to the third fuse first terminal and third fuse second terminal is connected to start to delta starter. For our understanding purpose, these all connections are connected internally. From R we need to give two wires. One wire is to voltmeter first terminal and another wire is to ammeter first terminal. ammeter second terminal is connected to wattmeter first terminal, which is nothing but M. From M you need to connect it to C. From L is connected to R. From M to L there is internal connection is there, and as well as from C to V there is internal connection is there. Only need to give from L to R. From Y we need to connect 4 wires. One wire is to one from wire from Y to voltmeter 600 volts, and the second wire is from Y to first wattmeter 600 volts V. Here this V is a 600 volts, and third wire is connected to Y to second wattmeter 600 volts, and one more Y terminal is connected to Y of a 3-phase induction motor starter. Next Y 4 wires. switch it. Wait. First B. From B, we need to give a connection. From B is connected to second wattmeter M. Again, from M you need to connect it to C. L is connected to B. Here also for this wattmeter also from M to L there is internal connection is there, and from C to V there is internal connection is there. M to L is called as current coil because it is connected in series with the ammeter. For C to V is called pressure coil or voltage coil. This is the connections of the circuit diagram. If you are having RYB terminals, H. If you're having the panel board consisting of L1, L2, L3, here also the connections which are shown in the box are internal connections are which are connected internally from R. Here also you have to start from R. From R you need to give one wire to voltmeter first terminal, and one more wire is to ammeter first terminal. From R we need to connect two wires. One wire is to voltmeter, one wire is to voltmeter, another one is wire is to ammeter first terminal. From Y you need to give four wires. One wire is to voltmeter 600 volts, and the second wire is given to, the third wire is given to the first wattmeter 600 volts, and the fourth wire is given to the second wattmeter 600 volts. From Y you need to connect four wires. wire is to voltmeter 600 volts. One wire is to L2. One wire is to wattmeter 600 volts. Here is the wattmeter 600 volts. And one more wire is to second wattmeter 600 volts. From ammeter second terminal is connected to first wattmeter M. M is connected to C. Now the ammeter second terminal 10 amperes is given to first wattmeter M. Again from M you need to connect it to C. From L we need to connect it to L1 of the three-phase induction motor starter terminals. L1 L is connected to L1. We need to connect it to L1. From B you need to connect it to second wattmeter M. From M you need to connect one wire to C. B you need to connect it to second wattmeter M. Again from second wattmeter M you need to connect it to C. And from L you need to connect it to three-phase induction motor starter terminal of L3. Here L1, L2, L3 are three-phase induction motor starter terminals. Here also from M to L, C to V there are internal connections. No need to give externally. Again here also from L1 to L2 also, L2 to L3 and L3 to L1 which are internal connections of the three-phase induction motor starter winding. For wattmeters, M is nothing but main, L is nothing but load, C is nothing but common and V is nothing but voltage. Second wattmeter L is connected to L3. These are the connections. Now you need to start the three-phase induction motor with the help of star to delta starter. Close the TPST switch. Before closing, the brake drum must be loose. Now close the TPST switch. Once you are closing the TPST switch, you can observe the voltmeter reading. Here directly a 3-phase voltage is given, which is nearer to 96 volts. You need to multiply with 4 because we are connected to 150. Scale is 150. Actually we are connected to 600. Now start the motor using star to delta starter. First of all, you need to push into the star. Now you need to move this handle to delta. Now note down the readings. With the help of tachometer, measure the speed, which is 1498 RPM. Now apply the load gradually and again take the readings of corresponding current IL to speed. Now gradually apply the load and take the readings of ammeter, voltmeter and wattmeter. Now switch off the TPS. Start with the starter. Tabulate the values where VL is the line voltage and IL is the line current. Units are in amperes. For VL, units are in volts. Wattmeter readings W1, the units are in watts or kilowatts. MF indicates multiplication factor. Spring balances S1 units are in kgs, S2 units are in also in kgs. Speed RPM, RPM means revolutions per minute. Torque units are in Newton meter. Slip is in percentage. Input power equals to W1 plus W2, units are in watts. Output power is the multiplication of torque and angular speed. Angular speed is nothing but omega m, which is equals to 2 pi n by 60, and efficiency equals to output by input into 100. From the experiment, tabulate the values and do the calculations. Torque T equals to 9.81 into S1 minus S2 into R, where R is the radius of the brake drum. Out power equals to 2 pi nt by 60, where N is the speed. Input power equals to W1 plus W2. Percentage slip equals to Ns minus N by Ns into 100. Efficiency equals to out power by input power. Model graph. Here is the model graph of speed versus torque characteristics. These characteristics are also called mechanical characteristics of a 3-phase induction motor. Since torque is also mechanical and speed is also mechanical, the other graph is the performance characteristics of 3-phase induction motor, or the graph between output power in watts to the which are in x-axis and speed, IL, percentage efficiency and torque which are on y-axis as shown in the model graph. From the tabulated values we can plot the graph, and these are the corresponding graphs for those values. Result: you can observe that thus the brake test on 3-phase induction motor is performed, efficiency has been calculated at different loads, and the performance characteristics are drawn. Conclusion: in a 3-phase induction motor, the speed regulation is small from no load to full load. The maximum efficiency occurs at less than the full load condition, which are observed from the table as well as from the graph.
Please subscribe, share and comment if you like.